a soil, no? So strength of different materials. For steel, no, it is called a tensile strength. Okay. For concrete, it is called a compressive strength. And for your soil, it is a shear strength. Okay. And then, because of the shear strength, there is a presence of your pore water, which is a complex behavior. No? Napakahirap intindihin kapag andoon yung presence of pore water. Okay? With compared to your compressive strength in concrete and your tensile strength in steel. Okay? So what is a shear strength? Shear strength in soil is the resistance to movement between particles to physical bonds from the first one would be the particle interlocking. Second, the atoms sharing electrons at surface contact points. And the third, it is the chemical bonds or the cementation such as crystallized no calcium carbonate. No, napaka tawag dito um chemistry ganun na terms because of atoms, chemical bonds, no, like that, no. So what are the factors that can influence the shear strength of your soil? Okay, the first one, no, it was affected by the soil compaction. Okay, mineralogy, grain size distribution, shape of particles, pore fluid type and content, no, ions or grain and in pore fluid, no. The second one would be the initial state. Okay, for initial state, it is a state that can be described by terms such as the loose, dense, over consolidated, normally consolidated, stiff, clay, no, na hindi ko na ilagay, soft, no, and so many, no. It is just a description of what sand, no, that is being used or that is being tawag dito, described, no. And then the third one would be the structure, no, which refers to the arrangement of particles within the soil mass. Okay, the manner in which the particles are packed or distributed. Okay, the manner which the particles are packed or distributed. Okay, think of that. No, features such as layers, voids, packets, cementations, and etc. are part of your structure. Okay. The next one would be the shear strength. No? So in reality, no, a complete shear strength formulation would account for all previously stated factors. Okay. So the behavior is quite complex due to the possible variables stated or sometimes due to your pore water. Okay. And then the laboratory tests commonly used by a direct shear and unconfined compression testing, no. So that is the common, but there are laboratory tests, no. I think 5 laboratory tests ata yun yung ginagamit, but the most common use na that being used, no, it is the direct shear stress, the direct shear test and the unconfined compression testing. Okay. So soil failure and the shear strength, no? For soil failure, it is usually occurs in the form of shearing, no? Along internal surface within the soil, okay? Thus, the structural strength is a primary, okay? The structural strength is a primary function or shear strength, okay? Shear strength is a soil's ability to resist any of your any sliding forces along internal surfaces within your soil mass. Okay? This is an example of failures, no? Kung saan yung sa shearing stress along your internal surface, no? Consider this 3D, no, part of your soil, no? Ito na lang yung black and white na ganun niya. Kumbaga, you dig or you excavate, no, a certain soil, no, and it is a homogeneous soil, no. Therefore, there is a failure doon sa mismong tawag dito, doon sa mismong soil ninyo, no? And then kung ano yung characteristics niya. Okay? So, mass wasting shear failure. Okay? Ano nga ba tong mass wasting, no? Mass wasting, no, it is just the process, no, involving movement of your rocks or your mantle rocks, no, and then that is controlled directly by your gravity, and that includes such as gradual movement as creep, no, and salifaction, and such as rapid movement as rock falls, no, yung kita natin dyan, yung landslides, no, and mud flows and other like, no. So that is the mass wasting, no. This is an example of your mass wasting landslide, okay, or the rock falls, okay. So shear failures for earth dams. I know. I believe that you are you have an idea or knowledge about the earth dams. Okay, so it is just commonly known as earth fill dams. Okay, that is built by compacting, no, successive layer of your earth, no. So just is a short or common meaning for the earth dams, no? So shear failure under your foundation or your foundation load, no? For an example, you put a foundation, no, and then you excavate it, no, below the soil property or the soil layer, no, with a ultimate load, no, with a B or width of your foundation. Then therefore the first layer or the first portion of your soil that reacts or has an effect, no, would be directly the bottom of your foundation, and then succeeding na yung malapit na sa kanya, no, until such time na doon sa pinakadulo na ang makakarating yung reaction or the effect of your foundation. Okay? So for an example, no, shear failure. So soils generally fail in shear, no? In shear. Okay? For this time, no, it is a strip footing, no? Just one. Okay? And then this is the motion or this is the movement, no? It rotates to that point, okay? And then for an embankment, no, mobilized shear resistance naman siya. Okay? So ganyan yung nangyayari, no, kapag sa strip footing, no, at sa embankment. Okay? So at failure, no, shear stress along the failure surface reaches the shear strength. Okay? Ayan. Shear failure like that, no? This is the common failure dito sa mga nabilugan, which is the failure surface, no? And then the soil grains slide over each other along the failure surface. Okay, there is no crushing of individual grains. Okay, and this is the mechanism. Okay, for the mechanism, no, for an example, for the embankment, no, this is the common type ng failure niya. Okay, and then uh, we consider this portion, no, kung saan yung failure plane, no, there is a effect of your tau, no, and your phi. Later on, we will determine what is the meaning of your tau and your phi. Okay? Ayan, nandito na. At failure, shear stress along the failure surface tau, no? Take note of the term. What is the meaning of the tau, no? Tau, it is the failure surface, no? Reaches the shear strength, no? And TF, no, it is just a or the tau F, no, it is just a shear strength of your soil. Okay? So shear failures of soil, no, soils generally fail in shear, no. For an example, you have a retaining wall, no, kagaya sa topic natin kahapon with regards to the lateral earth pressure, no. For example, this retaining wall is tend to support this section of your soil, and then because of successive, no, or because of the poor water, no, there is an effect, no, with your retaining wall. Therefore, itutulak ngayon ni soil si tawag dito si retaining wall, no, such that the motion or the pressure upon the retaining wall, no, is increases, no. Therefore it is just a active, no, kumbaga active lateral earth pressure siya kasi si soil ang tumutulak sa retaining wall instead na dapat si retaining wall ang magtutulak kay soil. Okay? And then that is the failure surface, no, because of the effect of your soil to your retaining wall, no, they consider the tawag dito yung pagbaba, no, nung si soil, no, sa mismong original niya, no? Therefore, no, yung sliding doon sa mismong shearing, no, ng soils, no, between the two soils, no, therefore that would be your failure surface, okay? And then mobilize shear failure resistance yung nangyayari. Okay? So at failure, no, shear resistance along the failure surface or your mobilized shear resistance, no, reaches the shear strength. Kaya nagbibigay, no, or kaya nangyayari sa retaining wall mo yung ganyang failure. Okay? Um, there more column failure criterion, no. This is the more column criterion that is being used, no, for soils, no. For an example, no, you have a as you increase the tau or your failure, no, there is a failure slope, no. There is a failure slope. Okay. So tau, no, take note of this formula, no. Tau F, no, it is equal to BC. Hindi pa natin. Okay? TF or the tau F, no, or it is the maximum shear stress is equal to the cohesion plus your phi tan uh, stress tan phi, okay, or the normal stress. Okay, for an example, this is your failure plane, no, this slanting, no, as you increase the failure plane, no, there is a internal friction or there is a friction angle, no? Dito yung kanyang friction angle. Or if you are here, no, dito sa part na ito are ang friction angle, no? It is just a simple mathematics, no, na kung saan yung angles, no? And then the increase, no, kung saan nagsimula yung failure mo, it is caused by your cohesion. Okay? So upon increasing your shear stress, no, there is a increasing in failure envelope or there is increasing in failure slope. Okay? So tau F, it is the maximum shear strength of your soil can take without failure, no, under normal stress of phi ay of mu, ano ba tawag dyan, basta yun na. Okay, so in terms of total stress naman, no, We also consider the past drawing, no? It is just yung pagkakaiba niya lang, no? Tawag dito, yung placing ni tau F, no? Yung pag-increase ni tau F, no? And because of the increase of your friction angle. Okay? So here, no, in terms of effective stress, okay, your tawag dito, your pore water, no, pressure, no, can be determined by the change of your stress, okay? Wherein your change in stress, it is the original stress minus your pore water. Okay? Shear strength consists of two components. The first one would be the cohesive, no? And the second one would be frictional. Okay? For an example, we have a drawing for the first term, no? The tau F, no, or the normal stress, no, the shearing stress, no, tau F, it is equal to the cohesion plus your final, no, final na si stress mo tan of your V. Okay? So, as you can see, there is no difference with the drawing later on. Okay? And then the cohesive component, andoon siya part. Your tan fee, no, it is here, no, if you are pays some fee doon sa tawag dito, doon kayo magsimula doon sa intersection mismo nitong red, or itong si failure envelope doon kay y-axis or your tau. And then considering yung ano tawag doon, yung mathematics na SOHCAHTOA, no? Therefore, makuha nyo itong si tau F tan phi. Okay? Considering the tau F, no, yung phi F, should I say, no, phi F, this one, your x-axis, okay? And then your y-axis, no, would be the pf, okay? So, another criterion, no, or just a frictional naman siya, component, no, cohesive component, the same as it is, walang pinag-iba, wherein your C and your are measures of shear strength, no? So that the higher the values, the higher the shear strength. Okay? Habang lumalaki ang iyong values, lumalaki din ang shear strength. Okay? For the shear strength of your soil, no? For granular soil, no? Tau it is equal to your stress tan phi. Okay? So it is just a simple, no? Simple mechanics. Okay? So that for soils that is free, no, angle is called, no, angle internal friction or friction angle, no, or angle of repose, no. There are different names for your fee. Okay? It is just a ganun lang. Understanding, no? Mabilis mo namang mahalata, no? If this is your fee at yeah, if this is your normal stress, no, or your fee later on, your fee, should I say, no, sorry, fee, no. Kung kumbaga may sinabi na siyang angle, no, it is considered as your fee. Okay? And then for your grain soils, no, their strength is apart from friction, okay? Because of your internal forces holding the particles together, no? So this is a cohesive soil, no? In Coulomb's law, no, they extended to cohesive soil, which is your tau is equal to your normal stress times your tan phi, no, or your internal friction, internal angle plus your cohesion. Okay? So in case of saturated soil, no, yung stress mo dun sa una, no, ay magiging stress prime or your change in stress. Okay? Yun lang yung pinagkaiba niya. So these are the common tawag dito, drawings no or diagrams no na nangyayari no in your shear strength of your soil kapag nilipat mo na siya to more or more circle no. For an example, you are given with a general case no wherein there is a known cohesion no and then your internal friction wherein greater than zero siya no. Pero no, if your cohesion it is equal to zero no and your internal friction is greater than zero no, therefore it is a non-cohesive soil no or it is a granular soil no. So the reference point no of your failure zone or your failure plane no, it is located exactly no at the midpoint of your tau and your stress kung saan sila nag-meet. Okay? And then if your cohesion is greater than zero, no? And then your internal friction is equal to zero, therefore, no, it is just subjected to a tawag dito, a vertical stress lang, no? So that there is no another shear failure plane. Therefore, instead of a increasing or sloping failure plane no horizontally na lang yung failure plane mo because of the value of zero. Okay? Determination of shear strength parameters of your soil, which include your C, your phi, and then your C prime and your phi prime. Okay? For laboratory tests on a specimen taken from representative undistributed samples, no? Most common laboratory test, it is the direct shear stress and your trial shear stress. Okay? But for field stress, no? Uh, there are so many. Yun yung vein shear test, the Torvein, the pocket penetrating meter, full cone, pressure meter, static cone penetrometer, standard penetration test, no? Ang hirap basahin yung mga ganyang bagay, no? So yun, the commonly type, no, na ginagamit natin, no, that we are being used in solving the shear strength, it is the two, which is the laboratory test, which is the direct shear, direct shear test, and your trial shear test. Okay? So for field condition, no, for an example, the before the construction no, or bago kayo bago or kung baga there is no movement on into your soil no. So normally no ganito yung mangyayari wherein your shear stress vertically no and your shear stress horizontal no. Ganyan lang yung kanyang effect no. Pero kapag meron na kasing tawag dito after the construction, no, magro-rotate, no, or there is a movement with your soil samples, no, with regards to your shear, no. So that would be your the after construction, no. There is a another movement, no. Instead of solo strength, shear strength doon sa upper, dinagdagan ng change of shear. Okay? So, yan, mga yan. Bilisan na lang natin. Doon na lang tayo sa summary later on. Okay? Pero ito, for trial sa trial test ganito sana. There is no ganon, there is no different there is no difference with to the other one, no. The only thing is instead of tension doon sa horizontal niya, nagkakaroon na ngayon ng compression. Therefore, all of them are compression, no? Kino-compress nila yung soil until such time that there is a effect or there is a friction, no? Kung saan nangyayari ang sloping, no? Or just a failure plane, no? Nagkakaroon siya ng failure plane, no? Which is your phi, it is more than zero, okay? For direct shear naman, there is a tawag dito, cohesion mo is equal to um, greater than zero, and your phi, no, or internal friction, it is a equal to zero. Okay, so that one. So this is the diagram of your direct shear apparatus, no? I think for the soils, wala tayo ata nito. So direct shear test is the most suitable for consolidated drain test. Okay? For preparation like that, no? Porous plate. Okay? So ganyan ginagawa nila, no? For preparation of your sand specimen. Okay? So madugo yung ginagawa nilang experimentation. Okay? Like that. Okay. Tinutulak ngayon, or there is another pressure dun sa bottom part mo, okay? Until such time that there is a effect, no, or there is a failure doon sa mismong pagitan, or doon sa mismong tawag dito, contact ng soils, no, with respect, no, of, or with the additional force, no, doon sa mga marbles. Okay? So this is the common type of apparatus. So old na talaga siya. Siguro kung bibili ang USL ng ganito, napakama. So the analysis for that test, no, the normal stress, it is just equal to the normal force over your area. Okay? So stress is, it is equal to your force over area lang naman. Okay? And your tau, no, or your shear stress, it is equal to your shear resistance, no, divided by your area, no. So take note that your cross-sectional area of the soil sample, no, changes with the horizontal displacement. So what is the relationship of your shear stress, or your to your shear displacement? Okay. So upon increasing, no, because of the dense sand or the over-consolidated sand, clay, no, there is a part, no, kung saan sobrang taas, no, ni tau or your shear stress, no, until such time na mag-feel na siya, bababa na yung kanyang value. Okay? So that would be. And, natin. So, a gentle reminder lang, no? So, sand, it is a cohesionless. Therefore, your C, no, it is equal to zero, no? Take note of it, no, kapag hindi sinabi yung cohesion, no, if there is no given cohesion, and then they specified the type of your soil, no, for an example, if this is and therefore it is a cohesionless because of the tawag dito, because of the unpresent, no, or tawag dito, hindi ko na maalala, basta yun. And then the direct shear stress tests are drained, no, and pore water pressure are distributed, okay, hence your mu, no, is equal to zero. Okay? Or your pore water stress, no? It is equal to zero. Therefore, your phi, it is equal to your stress, no. Your phi prime, it is equal to your phi, no? And your C prime, it is equal to C, which is equal to zero. Okay? So, we will not take note of it. are the tubes or the apparatus that are being used, no? So, yun, marami talaga silang apparatus to. It is a old apparatus na, no? Kung sa era na natin yan. Yan. I think we have these apparatus sa SMTL. I think lang. Hindi ko alam kung ang andun pa. And then this one, no? May ganito tayong apparatus din, which is the UTM, no? So this is the diagram, no? If no there is no shearing stress or there is no phi, no, or given angle, no, or angle of friction, no. Therefore, it is just a horizontal, and then you make see more circle lang naman, no. Because of the name circle, no, we just draw a semicircle or a circle itself. Okay. So the summary, no, shear strength of your soil for more column failure criterion, no, your tau, it is equal to C plus your normal stress times your tan of internal friction. Okay? For direct shear, kapag ito ay normal stress, therefore, your stress is equal to your P normal or your normal force divided by the area. Okay? And then for the shear stress, no, your tau, no, it is equal to P, wherein your P there it is your shear force, no, over your area. Take note that if there is a shortening of length, no, kapag may pag-iiba or there is a change of your length, no, therefore the area, it is equal to your area original divided by 1 minus your Young modulus, no, or your strain. Sorry, that is strain pala, no. AO, it is the original, and your E, there, it is just like kasi ni Young modulus, no. So ang maarteng E, no, it is E strain, no, wherein your strain, it is equal to your change of L or yung pag-iiba niya or yung increase ng length, no, divided by your original length. Okay? So for shear strength of your soil, no, for example, there are some parameters, no, for friction, no, in dry soil, no, it's large, no, in wet soil, it is small, and in very wet soil, your friction is 0. Okay? And for cohesion, for dry soil, maliit, no? For wet soil, no, because of the presence of your pore water, no, lumalaki siya, wherein larging, no, and then in very wet soil, no, disregarded yung kanyang tawag dito, ang kanyang cohesion. Okay? For column equation, no, yan yung kanyang formula. There is two types, where the cohesionless and your cohesive soil. For cohesionless, no, disregard mo lang CC, okay? To your, based on your first formula, okay? Wherein, yung tao mo dyan, it is just your shear stress, your, tawag dito, yung arting may O na may ganyan, it is a normal or your axial stress, your C, it is the cohesion, and your phi, it is your angle of friction. Okay? For direct shear, no, yun ang sabi ko, in equilibrium, ganito lang yung pag-intindi, no, ng more circle of your soil or the shear strength of your soil, no. We just put a semicircle, no, doon sa mismong connection or failure plane, no, para ma-determine natin kung saan nagme-meet yung dalawa. Okay? For an example, this is a example of a cohesionless, okay, of soil, no? Kumbaga, there is a zero cohesion wherein yung mismong start ni failure plane, no, it is from the intersection of your tau and your normal stress. Okay? So upon increasing your fee, no, or your ECA, increasing also in failure envelope or your failure plane. Okay? So the intersection or where your failure plane, no, meets your stress in your soil, no, that is your tau, no? Doon kinukuha si tau. Okay? So later on, we will determine the different types or the different parts of this figure. Okay? So for cohesive soil naman, no, there is a presence of your cohesion. Therefore, hindi na siya mag-start, no? Yung failure plane mo will not start on a specific plane wherein kung saan, no, where si tau at si normal stress ay nagmi-meet. Okay? So, yun. For a trial shear stress, no? Please take note of these notations or the meaning of those values, no? Yung um, stress 3, change in D, stress 1, and stress. Okay? So, yun. Kasi, there are malilito kayo, no? Tawag dito, just for an idea lang, no? Si mu1 or si stress 1, yan lang yung tawag dito, yun yung sinaisip ko lang at si mu normal stress, no? Kasi the remaining na tawag dun sa mga pressures, mga ganyan, no? As you can observe, no? Pressure, stress, no? Kapag wala na dito sa mu1, therefore it is a mu3, no? So yun, parang hindi na ako nahihirapang mag-isip pa kung ano man yung tawag doon. Okay? So mu1, it is the maximum axial or normal stress at failure. And for your mu1, it is your major principal stress. Okay? So parang si mu1, no, ang laging nagagamit na pangalan, it is a major principal stress. Okay? So kapag sinabi ng lateral pressure, no, it is understood as your normal tree. Okay? So yun. And then this will also your tau, your C, your phi, your angle, your R, your tau max, no, or your maximum stress or shear, your normal stress with respect to your tau max. Okay? So for cohesionless soil, no? So ito na yung sinasabi ko, the different figures or the different parts of your Mohr circle. Okay? For an example, we have a shear, no, at vertical, and there is a axial or your normal, no, from horizontal. Okay? So this is a example of a cohesionless, therefore there is no cohesion. Okay? So the start of your failure plane, it is in 0. Okay? So the from your tawag dito, kung doon sa 0, no, hanggang doon sa final place or the last portion of your diameter of the circle, no, that would be your mu1. Okay? Or your normal one. Okay? And then yung doon sa mismong 0, no, hanggang doon sa start ni Mohr circle mo, okay, that would be your uh, normal tree. Okay? That is your normal tree. Okay? So if the question is asking you about the major principal stress, no, therefore your stress 1 is the thing that you have to determine. Okay? And then your if you are, if the question is asking you about the um cell pressure or your tawag dito ano pa yun? Liquid pressures, mga ganyan. Yung mga pressures or your chamber pressures, no? It is the ano tawag dito? Normal 3. Okay? And then doon sa mismong intersection ni failure plane, no? Kung saan nag-meet yung si failure plane, no? At si Mohr circle, that would be your the distance from horizontal, no? It is your stress or your normal stress. Okay? And then simply lang si Mohr circle, kunin lang natin si radius, no? And then simple mathematics, no? Your phi, the location of your phi, no? It is just this one, no? Kapag ililipat mo siya doon sa mismong Mohr circle, okay? So this one para ma-determine natin kung gaano kalaki, no? Yung distance na to, yung dito hanggang dito, okay? Or the other around, no? This one and then this one, and then we just add the chamber pressure, no? Or the chamber stress, no? P3, no? To get the normal stress, okay? So simple mathematics and understanding lang si Mohr circle, okay? So this is the formulas, no? To determine the different stress or pressures in your Mohr circle. Okay? So just follow these tawag dito, just follow these criterias or these formulas. Okay? Hindi naman kayo malilito kapag nasa tamang pag-iintindi nyo sa mga problema. Okay? And then, if there is a cohesive soil, no, yung kanyang cohesion, no, hindi, no, yung kanyang shear failure, no, ay mag-i-start na dun sa mismong, hindi na mismo dun sa zero, wherein there is a pagtaas or there is a increase of your shear failure because of your cohesion. Okay? And then same lang yung drawing, no? The only difference lang is the presence of your cohesion. Okay? And then kapag unconfined or in, no, there is no internal friction, no? Therefore, there is a cohesion, therefore um horizontal lang yung failure plane. Okay? Horizontal lang yung failure plane. So napakadali lang kapag unconfined compression tests. Okay? So here is the example number 1. Okay? So it is believed that the shearing strength of a soil under a certain condition in the field wherein your cohesion it is equal to 0.2 tons per square feet and your friction angle it is equal to 22. Okay? The first thing to determine is what minimum lateral pressure, no, would be required to prevent, no, to prevent to prevent failure of the soil at a given point if the vertical pressure were 4.5 tons per square feet. And then B, compare the shear strength or shear stress at the plane of your failure. And letter C, compute the angle of shear failure with respect to the horizontal. Okay? So for letter A, no, as you can see, it is the minimum lateral pressure. Okay? So hindi naman siya yung tawag si mu1 or si normal 1, no? Hindi naman si normal 1 yan. Therefore, it is the normal 3 ang hanapin natin. Okay? And then for letter B, compute the shear stress at the failure at the plane of failure. Therefore, that is your tau, no? That is your tau. And for letter C, no, compute the angle of shear failure with respect to the horizontal, no? So it is just your theta. Okay? So let's move to the paint. Nilipat ko na agad ito. So this one, no? Nandito yung example, no? The first thing we have to do is to draw the diagram. Okay? To draw the diagram. So there is a presence of cohesion. Therefore, yung kanyang failure plane, no, ay mag-start doon sa mismong taas or hindi doon sa mismong zero. Okay? And then there is a 0.2 tons, no? There is a increase of 0.2. Okay? For an example, this is your tau. Yan na. Okay? And then this is your normal stress. Okay? Ilagay na lang natin si tau. Then your stress. Okay? And then because of the presence of the cohesion, no, zero na lang dito, zero. And then andito si 0.2. 0.2. 0.2 your cohesion. Therefore, for an example, this is your failure plane. Okay? Sorry kung hindi gaano. Okay, yan, ganyan na lang. And then your internal angle, which is equal to 22 degrees. Okay? And then let's draw the more circle. Okay? Parang hindi na ataabot dito. Wait. Let's erase this part. So, test na lang natin later on, guys. Purahin na lang natin tong failure plane. Baguhin ko na lang. Okay. So, so yan na. So this part, no, is your 22 degrees. Ayan. Yes. Okay. And then, to determine the value of your A, which is your stress trait, no? So from this part, no, di ba sa drawing, this part hanggang here, before the start of your more circle, it is your normal tree, okay? Or your lateral pressure, okay? And then, um, this part, the start hanggang sa end naman ni more circle, it is your change in stress, okay? Change in stress. And then, the whole, no, from the start dun sa mismong line or dun sa mismong vertical, no, hanggang dun sa end ni more circle, it is your normal stress or your stress 1. Okay? Stress 1. Okay? So the vertical pressure, no, where is 4.5 tons, no, it is the vertical pressure. Therefore, this one would be your mu 1. Okay? Or your normal one, 4.5. Okay? And then, ano natin kunin mamaya si mu 3, si normal 3, no? Kunin, i-draw na lang muna lahat natin yung mga kailangan. Okay? So, the next thing to determine is yung draw ka ng from the midpoint, no? Hanggang dun sa failure plane kung saan nagmi-meet si failure plane at si more circle. Therefore, here. So, this is your R. Okay? This is your radius. Okay? And then, sabi ko nga, kapag i-extend mo, no, yung intersection ni shear failure hanggang doon sa mismong tawag dito, horizontal or si shear, no, for this type, no, yung this one, yung intersection ni shear failure at ni more circle hanggang dito sa mismong bottom or doon sa plane ni normal stress or din plane ni stress, no, that would be your tau, no? It is the height of your tau. Okay? Tau. That is your tau, no? And then this phi dito, no? 'Di ba kapag sa mathematics natin, yung phi dito, it is just the phi of here. Tama? Okay lang ba? Okay lang ba kayo? Kikinig pa ba? Okay. And then, 'di ba this part, no? Dito sa from 0, no, hanggang doon baba, no, or kung saan natin binaba si tau with respect to your phi, it is just your tawag dito, your normal stress, di ba? Tama ba doon sa figure natin kanina? Okay? So, to have a specific or para mas mabilis yung pag-drawing natin, we just extend yung shear failure to the left. Okay? Mag-extend lang tayo to the left para mas mabilis yung pag-intindi natin, no? Doon sa drawing mismo. Okay? So, there is a additional lang, no? Pero, dinidisregard lang naman din yan, no? Yun lang para mas mabilis yung pag-intindi natin. Okay, later on. So, kunin natin tong x. Yan, x. Okay? So, simple mathematics. Sige, let's move on. So, di ba, kapag kunin natin si x, it is just, if this is your fee, no? This is your fee. Wait, this is also your fee at 22 degrees. Okay? So, so katawa, para kunin natin yung x value, no? Tan, tan, is equal, tan fee, okay? Tan fee equal siya kay, so katawa, opposite over adjacent, wherein it is equal to 0.2, tama? 0.2 divided by the value of your x. Okay? So therefore, tan of 22, it is equal to 0.2 divided by your x value. Okay? Therefore, your x is equal to, ano si x? Ano si x natin? 0.5. Tama? Okay. 0.5 yung x value natin. Okay? So, kapag meron na tayong x value, okay, may x value na tayo, kunin naman natin doon sa with respect of r. Dito kay r naman. Okay? Okay, sa r naman tayo. At r. The radius. Okay. So, kunin natin dito sa may r part, no? This one, yung r. And then, with respect to this one. Okay? Dito tayo. Hindi muna dito sa part na to. Okay? Mas maganda dito kasi meron tayong x. Okay? Meron din tayong 22 degrees. Okay? So katawa, sine, opposite, over, opposite over adjacent. Hypotenuse, should I say. No? Sine opposite over hypotenuse. Okay? Wherein sine times your phi is equal to opposite, which is your r. Okay? Your r divided by your hypotenuse. Saan ang hypotenuse natin diyan? Di ba yung nasa bottom part? Tama? Kasi this is your at r. This is your 90 degrees. 90 yan. Okay? So, yun. So, at r, no? Sine of your phi is equal to r divided by your hypotenuse, which is x, no? X plus your phi 3, no? Or your phi 3 plus your uh, r, no? It is just your r, okay, plus your radius, okay? Therefore, sine of 22 equal to your R, no? Yun ang kinukuha natin. Your R divided by the quantity of 0.5, no? And si V3, no? Hindi pa natin nakukuha si V3. Kunin natin. V3. V3 as your R. Okay? So, yun. Kunin natin si V3, no? In terms of R, no? In terms of your R. Okay? Si V3 equal siya kay 0 V1, no? Which is your V1 minus your 2R. Okay? Si V3 equal siya kay V1 minus your 2R. Okay? Or in the other around, no? It is equal to normal 1. It is equal to your normal 3 plus 2 times of your R. Okay? So yung normal 1 which is equal to 4.5, no? Equal kay normal 3 plus your 2. Okay? Therefore, kunin natin in terms of RC3 para i-substitute na lang natin later on. Okay? So, si mu3 is equal to 4.5 minus 2 of your R. So, yan na. Substitute mo na lang to. No? Equation 2 na lang. Equation 2. Equation 1. Then, substitute si equation 1. Substitute equation 2. Equation 1, equation 2 to equation 1. Okay? Therefore, ang makukuha mo, no, si sine 22 ganun na siya. Sine 22 is equal to your R divided by your 0.5 or your quantity 0.5 plus, no, since it is OR, no, or your normal 3, no, which is 4.5 minus 2R. Okay? Then, i-add natin si another R. Therefore, ano yung si R natin? Ano yung R natin? Ano yung R natin dito?
Pointer
Ano?
36.
1.36. Ano pa yung isa? 36.
3, sir.
That is your radius, no? Therefore, di ba sa letter A, we determine the value of your lateral pressure, which is your normal 3, di ba? Therefore, substitute lang natin si R kay equation number 2, which is your V3 equal to
1.774, sir.
4.5 minus 2 of R. 2 ER na 1.55. 363. Ano yung sagot? 1.7 ba?
1.7 po.
1.77. Okay? That is in tons, no? Tons per square feet. Okay? So this is your uh, answer in letter A. Okay? Letter A. Dito na lang natin singit. Okay? Diyan na lang. Yan. Okay? So that is for letter A. Letter B, compare the shear stress at the plane of failure. So basically, no, it is your T. So this is your value. No, kunin natin daw ito, no, yung vertical na ito, yung with respect to your shear stress at plane of failure. Okay? For letter B, it is equal to tau. Or T. So, hanap kayo ng kita yung. Sige, ganyan na lang your tau. Okay? And then, si tau mo, therefore, yung T, it is equal to, paano natin kunin si T, no? With respect to your R. Di ba si R dito? And then this area or this theta, it is equal to 22 degrees, di ba? It is a dito. I don't know kung ano na yung law sa mathematics, yung ganito. Kapag ano yung theta mo dito, and then interconnected with the line, no? Therefore, your theta here is just equal to the theta of here or here, no? Or pwede dito sa plane na to, no? That is your theta, okay? Therefore, yung ganun mo with respect to your tau, no? Tau is equal to uh or cosine, no? Cosine adjacent, which is your tau, divided by your r, okay? Or your tau, it is equal to cosine of your r, okay? So your tau, it is equal to r cosine of your phi for your 22. Okay, your r, it is equal to 1.77 times your cosine of 22. Therefore, the value for tau, it is equal to wrong. 1.77 ba nilagay natin? It is 1.3 kasi R pala siya. 1.363. What is the value for this? 1.363.
1.26.
1.
26.
260.
Okay, 1.264 in tons, no? Tons per square feet. Square feet. Okay? This is your tau. Okay? And for letter C, for last letter, determine the value of your theta. Okay? Saan ba nakakabit si theta? Okay? So si theta, it is the angle of your shear failure. Okay? So si theta, no? Angle of your shear failure. Saan ba natin makukuha si angle of shear failure. Saan natin pwedeng tignan si angle of shear failure dyan? Anyone? Saan natin pwede makita si angle of your shear failure? Anyone from the class?
Taas ng cohesion, sir.
Taas ng?
Cohesion.
Saan dito? Saan part? Dito?
Yes, sir, sir.
Si L dyan ba yun?
Yes po, sir. Hindi ko sure.
Saan part? Dito? Dito ba sa tinuturo ni cursor? Or dito? Letter A dito, letter B dito, letter C dito, letter D ito, or letter A doon sa tawag dito. Ang dito part. Dito.
Diyan po ata sa E.
Dito. Letter E. Letter E ba siya? Anyone? Di na? Di na yun? Di na. Gising na di na. Di na mama. Di na? Where is the angle of your shear failure? Or we just draw another line here with respect to your tawag dito, with respect to your first na part, no? Wait, okay. Letter C, i-delete muna natin to. Okay, ito na. So the location of your angle of your ano yung tawag doon? Your shear failure angle, no, with respect to the horizontal, therefore here, no, andito siya. So let's draw another ganun here until to this part. Okay? Yan. And then this is your theta. This is your theta. Okay? So diyan nakalocate si theta. Okay lang? So there is a common formula, no, to determine the tawag dito, to determine the angle with respect to your shear failure, no. Ito lang siya. For letter C, your angle it is equal to theta equal to 45 plus it is just 45 plus your phi over 2. Your phi over. O yan lang, no? Ganyan lang yung shortcut or ganyan yung common na formula for your to determine the angle of your angle with respect to your shear failure. Therefore, 45 plus the quantity of your fee, which is, ano yung fee natin? Fee. Ano yung fee natin dyan? 22. Tama? Yeah, 22 yung fee niya divided by 2. Therefore, it is 11 plus 45. It is just 56 degrees. Okay? It is just 56 degrees. So, yan lang. Yan yung kanyang, dito, yan yung kanyang degree lang. Okay? Hindi ko na ganun na bold letter. Let's brush it first. $56. So, yeah. Yan lang yung kanyang ganyan. Okay? May katanungan ba? Wala. Wala naman. Naintindihan nyo ba? Kasi part of your quiz mo later on to. Itong ganito. Itong shear stress. So, there is another example pa. Siguro tapos natin to before our time. So, kung wala nang katanungan doon, save ko lang, baka mawala. Okay? For the next example, from a consolidated drain test, the normal stress, okay? Yan yung nasa baba natin, normal stress. On the plane of maximum shear in a triaxial test, should I say, is equal to 480 kilopascal. Okay? 480 kilopascal. And then, the soil specimen tested was normally consolidated soil. Okay? With a maximum principal stress failure equal to 640 kilopascal. Letter A, to determine the chamber confining pressure. Letter B, compute the angle that the failure plane makes with the principal stress, or yan yung theta natin. And letter C, compute the normal stress at the plane or at the failure plane, or plane of failure. That is your tawag dito, yung sa stress, ganun yun, parang normal stress. Okay, so yeah, let's draw again. Mas magandang gamitin natin ito kasi okay. Since walang binigay na cohesion, there is no cohesion on, therefore it is a sand, so cohesionless. So zero ang cohesion niya. Okay? Draw muna natin si circle, So, ayan. Cohesionless siya. Therefore, mag-start yung failure plane hanggang doon sa mismong zero. Okay? So, ayan. And then, kunin muna natin. So, this is your tau. This is your tau. And then, from this part, into this part, this is your P3. And this part, hanggang dun sa end, it is your change of your fee. Change of your fee, no? And then from here sa plane, no? Hanggang dun sa end mismo ni more circle, no? It is your mu 1 or your normal stress 1. Therefore, it is equal to, di ba ang normal stress, no? Is normal stress 1, which is your maximum principal stress. Therefore, that is 640. Okay? $640. 640. Okay? Hanapin pa natin yung ibang given. Si 480. Saan nakalocate si 480? Di ba si 4, drawing muna natin saglit. Si from radius hanggang dito sa shear failure. So, approximately here, your radius, another one, yung si tau, or yung shear stress hanggang dyan, with respect to your x, no? So, yeah. So, this one would be your r. This one, your t. This is your tau also. Therefore, this one, let's see. Dito, hanggang dun sa radius, no? No, hanggang dun sa tau mismo. Sa radius. This is your dito, this is your maximum plane of your maximum shear na triaxial test is equal to 480. So this is your 480, no? From your R, no? Hanggang dun sa 3. Okay? So this is your 480. 480. That is your 480K pa. So, yun. Meron na. Lahat naman na ata. Given. Diyan na. Na-input na natin lahat ng given. Possible given. Okay. So, number one, compute the chamber confining stress. Diba si chamber confining stress, it is just the tree, no? Yung normal tree, no? So, yun. Normal tree. Letter A. Letter A. Chamber. Stress. Which is your normal. Okay. Normal tree. By using the normal tree, kunin natin. Normal tree, this one, no? Pwede natin kunin with the use of 640 or the radius, no? Or yung pwede si 480, no? So, dito muna tayo kay 640, the diameter. So, normal tree, it is equal to, tawag dito, 640, 640 minus normal tree. Tama ba? Times your plus 2r. Normal 3 plus 2r. Ayun. Normal 3 plus your 2 times your r or your radius is equal to 640. Tama lang ba? Normal 3 plus 2 of your r it is equal to 640. Sakto lang? Hello, sakto lang ba? Tama lang, no? Your normal 3 plus your 2 times of r it is equal to 640. Okay? That is for your equation 1. Equation 1. For equation 2, no? Dito rin tayo kay 480. Si 480, normal 3, no? Normal 3 plus your r is equal to 480. Okay? That is for equation. So, substitute equation 1 to equation 2. Equation 1, equation 2 to 1. Therefore, ano yung kanyang r? Or doon na tayo kaagad kay chamber confining stress kung ano yung 3 niya. Ano yung value niya? Yung R and your O3. O3 and your R. Ano yung O3 niya?
$320, sir.
320 kilo Pascal. How about the R?
160.
480 minus 320, it is equal to 160. Tama? 160
Yes, sir.
in kilo Pascal. So, yan. Ito na yung answer sa letter A. And then, sa letter B, yung katanungan sa letter B, compute the angle that the failure plane makes with the principal stress. It is just your theta. Okay? Your theta. Theta is equal to 45 plus no your phi over 2. Tama? It's just your phi over 2. Pero, wala pa tayong phi. Paano natin kunin si phi? By using your value ni R at ni 480. Di ba si phi is located here, no? Or here, kung si 480. Therefore, si phi natin, it is just P, it is equal to, sukat o sine opposite over, opposite over hypotenuse. Therefore, ang opposite niya, no? Sine opposite is your R, which is 160, no? So, sine of your phi, which is opposite 160, divided by your hypotenuse, which is this one, your 480. Therefore, your phi, sine inverse, no? Anong fee?
$19.47.
19.471. Tama?
Yes, sir.
Okay. 19.471 degrees. Okay? Degrees. Degrees. Okay? So may phi na tayo, then substitute lang natin sa letter B. Okay? Yung O, o yung angle, no? Yung angle, it is equal to 45 plus or 19.471 divided by 2. Therefore, it is equal to 45, 19. So 9, 8, 8, so 945. 54.73. 73? 73? 736. Ito ba? L? Si L dyan ba yun? Reyes, ito ba? Okay. So in degrees. So this is your letter B. And last one, your letter C. The question in letter C is asking for compute the normal stress at the failure or at the plane of failure. Therefore, normal stress, no? This is the location of your normal stress. Plane of failure, sabi nga. Therefore, this is the normal stress at the plane of failure. So, normal stress. Okay? That is your normal stress. Paano nga ba natin kukunin si normal stress? Okay? We use by using this one, tau. Okay? Kunin muna natin si tau para simpleng sine opposite over cosine opposite tangent pala. Tangent opposite of your adjacent. Tangent opposite over your adjacent. Okay? Kunin muna natin si tau. Paano natin kukunin si tau? By using your r, which is your r times your cosine. Okay? Cosine of your phi. Okay? So therefore, so letter C, your normal stress. Normal stress at failure plane. Failure plane. Okay? And si tau, no, by using your tau, it is equal to your tau natin. Tau, by using your r, no? Tau, it is equal to just r cosine. Tama? Cosine of your phi. Tama? Okay lang? Tama ba? Tau is equal to, with respect to this one, r. Cosine. Sakto lang, no? Tau, it is equal to r cosine of your phi. Wherein, tau, it is equal to your r. Ano yung r natin? Ano yung r natin? It is 160. Okay? 160 cosine of your phi, no? Which is 19.471. Therefore, it is equal to, ano yung tau natin? Point. Sakto? kilopascal. Okay, maitaw na tayo. So, kunin na natin si normal stress. Okay? Si normal stress, no? Normal stress, it is just a sine, a tangent, no? Tangent theta is equal to tau over your normal stress. Or your normal stress, no? It is equal to tau tau divided by tan theta. Okay? So your normal stress, paano ba? Normal stress, is equal to tau divided by tan of your theta, your phi, which is, ano yung phi natin? Yung phi natin, it is 19.471. 19.471. Therefore, ano yung normal stress niya? Tau natin is 150. Ganun na lang natin. Ayan, sige. Normal stress is equal to tau, which is 150.85 divided by 19.471. Tan pala. Tan. N. So therefore, anong sagot dyan? Si normal stress ay equal to 426.6738. Okay. Normal stress is equal to 426.673 in kilopascal. So that is your normal stress. So yan, ganyan lang umiikot yung more circle natin about the shear strength. Okay? Shear strength of your soil. Okay? Do you have any questions? May question po ba? About the others, may question?
None, sir.
Wala po,
None,
sir.
sir.
Wala kayong katanungan din. One of your quiz later yan, no? So lateral earth pressure and that one. Okay? So, sure kayo? Wala kayong katanungan dito?
Sir, send sa LMS yan, sir.
Yes, I will be sending this into your LMS later on. Send ko mamaya. How about the others? Do you have any question?